We are the Imperial Materials, a student research group from Lawrence Technological University aimed at addressing the material handling needs of workers at the STEP Northwest Resource Center. Before we can delve into the specifics of our project, however, it is important to understand exactly what STEP is about.
I'm Steve Slayton. I'm the director here in the Livonia Northwest Resource Center for STEP, Services to Enhance Potential. We work with people with disabilities to help them become as independent as possible, mostly through job development and job training.
Keeping STEP's mission in mind, it was our time now to observe opportunities which would lead to improved potential in the employees or subject matter experts at the Resource Center.
Some of the things we noticed on our site visits 1 through 4, we noticed that 1, the surface was stainless steel, so even if you had a stainless steel part on a stainless steel surface, it was hard to see, difficult to see where it fell, and it would also slide around on the table pretty frequently. Another pain we noticed was the sharp edge on the table. It didn't have a chamfer or a smooth edge on it, so when workers were resting their arms on the desk, it would dig in. After a few hours, it's pretty painful. Another pain we saw was the workers were grabbing from a communal bowl, so when one worker needed a part and the other needed a part at the same time, there would be a pause that would slow down production. Another pain we saw was just aligning the parts on the finishing tray took just as long to create the part as it did to align it on the tray, which further reduced productivity.
Pulling these pains together, we decided it was our mission to create a product which would improve the efficiency, product placement, and productivity of the assembly process. Over the next few weeks, we would do substantial research and utilize ideation techniques to gain a better understanding of what we wanted to build. So kind of like a quick justification for the design that we used. So basically, it's nice and simple. It simplifies the process of material handling at the site a lot. We have Area A. Basically, the reason for this area is it centralizes the entire process. Instead of the workers having to grab from all over the place to get their parts, it's now right in front of them, placed in these slots, and they can easily just grab the components, assemble them on surface B, and then move them over to the tray part 1, which accounts for the manual aligning, so they no longer have to align their parts, they no longer have to count their parts because it's a set amount of grooves. And then finally we have part 3, which is the wrist rest, to give them just a little bit of extra comfort when they're doing their job. Now it was time to assemble our working prototype. While we did manage to 3D print one tray, we were unable to print our counting tray in time for the 4th site visit, and therefore had to work with a short-handed product. Our product surpassed the majority of previously determined test target results. However, there were still improvements to be made. For example, for SME Dan, the hardest part was picking up dropped components as the plastic parts slid around on the PLA. For SME Jack, the biggest difficulty was aligning parts without the component tray. Our solutions? First, we sprayed rubberized adhesive onto the tray to prevent unwanted sliding of parts. Next, we managed to print our component tray, meaning manual alignment would be taken out of the equation.
This is the main workstation. We decided to coat the surface with a white rubber coating just to help with adhesion for the plastic on plastic pieces. Keeps them from sliding around.
So just a quick demo of how the tray actually works. Wrists or elbows go on the rest right here. Part is grabbed from here. Part is grabbed from here. Assembly is done on this surface. Once the part is finished, it is placed in one of these slots. Once all the slots are filled, the manager comes and checks, make sure all the parts are fine and good to go. This tray is moved on to the next station and another tray comes in here. We visited STEP one last time, this time to test our product with all final changes made. As you can see, there is a significant improvement since the last test, as the SME, Anna, easily assembles and aligns the parts.
Many of our folks have issue or desire to have things perfectly aligned or almost be obsessive about putting things in an order. So by breaking down the pieces into perfect squares like this, that is going to improve their efficiency and make them a lot happier because the fit is going to be automatic. The comfort level of working on a material staff, because counting now becomes a non-factor. As soon as a tray is filled, you know exactly how many pieces.
To cap off, we thoroughly hope that our design provides a positive impact at the STEP Center by allowing employees to operate to their fullest potential while at the same time reducing the number of inconveniences faced. At this time, we would like to thank everyone involved in this project, including the entire Imperial Material crew, Professor Morano, Dr. Huff, and Steve Slayton for making this all possible.